Hi everyone, this is lesson 3.2, parallel lines and transversals. Today we're going to use properties of angles formed by parallel lines and another line that we call a transversal, which is a line that goes through the parallel lines. So before we learn about the different properties, let's do a little exploration. So here at GeoGebra, we're going to be using this website throughout the year. In this applet here, I have two parallel lines labeled AD and FH. And I just want you to notice the angles that form. So these are the two parallel lines, and then GE or EG is what we call a transversal, a line that goes through the parallel lines. So with each parallel line, it intersects the transversal at a point. Here we have point B, and here we have point C. And with those intersection points, you form four different angles. So here, the way this is set up right now, it's 131, 49, 131 again, and 49 again. So one thing that you can notice is that vertical angles are congruent. So 49 and the 131. Another thing you can notice is then that 131 and 49 add up to 180. So these two form a linear pair, and then same with each corresponding set of linear pairs. They form 180 degrees. Okay, and then I want you to notice the relation between the angles formed at each vertex, B and C. So 131, 131, 49, 49, 131, 131, and 49 and 49 again in the red. So it's color-coded here. So, and I don't know if this applet will allow me to, here, let's press play, see what happens. Okay, so I don't know if this would let me drag. Okay, so this isn't going to let me drag FH out of being parallel, but if it wasn't parallel, so if I dragged it down and say it went like this, then would the corresponding angles still be congruent? So for example, would this angle, the blue angle, still be congruent to this blue angle over here? Well, the answer would be no in that case. So because they're parallel, you form these special angle relationships. And the purpose of this lesson is to talk about what those are. And I just wanted to, also point out this one. So angles formed by parallel lines and a transversal. Okay, so here we're showing corresponding angles. So corresponding angles mean that they're in the same position relative to the intersection point or the vertex. And then we'll talk about what these ones mean, but I can give you a short preview. Alternate interior means alternate of the transversal and on the interior of the parallel lines, versus alternate exterior, which are on alternate sides of the transversal. So one's on the right side, one's on the left side, and they're on the exterior of the parallel lines. So anything in here would be interior, and anything above or below the parallel lines would be exterior. And then same side interior, we'll also call that corresponding interior, would be on the same side of the parallel lines and on the interior. So same side of the parallel lines and on the interior. Notice that the same side interior are not congruent, but they are supplementary. And then same side exterior are also supplementary. And we don't do this one, we don't refer to this one too often. And the corresponding angles are congruent because they're on the same position relative to the vertex. So both above and to the right, or you can have both below and to the right. Okay, I'm going to link this applet in the folder for tomorrow. That way you can kind of play around with it yourself. So anyways, let's go ahead to the definitions. So I'm going to skip a few slides. All right, so corresponding angles postulate. So as you can see from this diagram, the corresponding angles are in the same position relative to the vertex, and they are congruent as we saw from the GeoGebra applet. So this says that if two lines are parallel and cut by a transversal, then corresponding angles are congruent. And I like to abbreviate it as just CORR, corresponding angles are congruent. Alternate interior. So alternate means they're on the opposite side of the transversal. Interior means they're in between the lines. In between. So this says if, I'm just going to use quotes so that I don't have to write it again. So the same thing that we said for the hypothesis above. So if two lines are parallel and cut by a transversal, then also alternate interior angles are congruent. And I like to abbreviate it as alternate interior angles are congruent. Alternate exterior. Okay, I always forget that I messed up this this diagram here. So let's try that again. How about let's label that 3 and that 5. So in this particular case, 3 and 5, well, actually, we could call it 1 and 8, actually. Let's do that. Call it 1 and 8. 1 and 8. So angle 1 and angle 8 are congruent. So if, quotes, if two lines are parallel and cut by a transversal, then alternate exterior angles are congruent. And then for consecutive interior, which means same side, they lie on the same side and interior of the parallel lines. And notice that in all of these, just to point out, all of these, the lines that are parallel are marked with an arrow. So if they're not marked with an arrow, then you can't tell for sure that they're parallel. And if you don't know that they're parallel, then you can't say these things. You can only say that these angle pairs are congruent or supplementary if you know that the lines are parallel. The if part has to be known. So it says if two lines are parallel and cut by a transversal, then consecutive interior angles are supplementary. They add up to 180 degrees. All right. So let's look at a proof here of the alternate interior angles theorem. So prove that if two lines are cut by a transversal, two parallel lines, then the pairs of alternate interior angles are congruent. So first we'll say that P is parallel to Q because that's what we have been given if two lines are parallel. So those are what are parallel. And then what we're going to say is, remember that for the corresponding angles is a postulate. In postulates, we don't have to prove them in order to use them in a proof. So we're going to use the corresponding angles postulate. Corresponding angles postulate to say that the corresponding angles here marked in the diagram, 1 and 3, are congruent. Angle 1 congruent with angle 3. And so one thing that you can actually say for the bottom, for step 4, is what you're trying to prove. So if you're trying to prove that the alternate interior angles 1 and 2 are congruent, then you can say angle 1 is congruent to angle 2. Now you don't know the reason yet, so you're going to have to wait on that one. But how about step 3? What else can we say from this diagram? What other things can we say are congruent to each other? Well, you have vertical angles, so you can say that 2 and 3 are congruent. So angle 2 is congruent to angle 3 because of the vertical angle congruence theorem. That's the short way to write it out. And then for step 4, you would just use the transitive property. Also, usually substitution we wouldn't use here because substitution is for equations, and this is congruence, not technically an equation. Let's look at what other examples we have. So we already said this. You can write this down if you want, but alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Consecutive interior angles are supplementary. So you can say that if you want, write it down again, but you should have already written it down, so you don't need to. Okay, and then let's just real quick then say which ones. Actually, I think we'll skip this particular diagram and just use the next one as an example. So let's classify angles 1 and 8. So 1 and 8 are on the exterior and they're on alternate sides of the transversal. If you want, you can highlight your transversal. I'm going to take a highlighter, highlight the transversal. Okay. So those would be alternate exterior. So if the measure of angle 1 is 132, the measure of angle 8 is also 132. Classify angle 5 and 3. So 5 and 3 would be consecutive because they're on the same side of the transversal and on the interior. So they're consecutive interior angles. Therefore, they are supplementary. So if the measure of angle 5 is 122, 180 minus 122 gives us 58. Classify 2 and 6. So 2 and 6 would be corresponding because they're on the same position relative to the vertex point, both above the parallel line and to the right. So corresponding. Corresponding angles are congruent, so this would also be 46. 7 and 4. So 7 and 4 are actually neither. So they're not, one is interior, one is exterior, and they're on opposite sides of the transversal. So they're not either of the 4 different angle types that we've mentioned. However, you can still say that angle 4 then, if 37 is 7, then angle 4 would be supplementary to that 143, because you would know this would be 143, and then these are alternate interior, which are congruent. And then 5 and 8. 5 and 8 are just vertical angles. Vertical angles are congruent, so this would also be 24. Diagram is not drawn to scale. There are many of these where the diagram will not be drawn to scale. So don't always rely on your diagram. Just rely on the numbers. 7 and 8. So 7, 8 are linear pair, so they're supplementary. Linear pair. Linear pair is the type of angle pair, and then supplementary is a property of that. So we would say linear pair in this case rather than supplementary. And then 78 degrees. Okay, so I hope that gives you a good background. I don't think that we need to do more examples. You'll see these examples in your lesson tomorrow. Okay, so have a great day.